What are the best prototyping techniques for new products? Imagine turning a rough idea into a real, touchable model in just a few days. That's the power of good prototyping techniques. They help engineers test and improve designs quickly and accurately. When creating new products, it's all about finding the right method to match the project's needs. Mechanical engineers use several key techniques to make this happen. Rapid prototyping is a popular choice because it can produce physical models from digital designs very fast. It includes methods like additive manufacturing, which is better known as three-dimensional printing, subtractive manufacturing like CNC machining, and molding processes. These methods let engineers see and handle their ideas early on, saving both time and money. For example, three-dimensional printing builds parts layer by layer from materials such as plastics, resins, or even metals. It allows for complex shapes that are hard to make with traditional tools. You can create prototypes that look and feel like the final product, and even test mechanical properties like rigidity or flexibility. CNC machining is another essential technique. It involves removing material from a solid block with computer-controlled tools. This method produces highly precise parts from metals or engineering plastics. It's perfect when prototypes need to withstand stress or requiring tight tolerances. CNC parts often look very close to what the final production parts will be. Molding techniques, like silicone molds or low-volume injection molding, are useful when you need multiple copies of a prototype that look and feel like the real thing. These are especially helpful after initial design validation, as they can be produced quickly and at lower costs. Before making physical models, engineers often start with concept sketches or simple virtual models. These early designs help visualize ideas and gather feedback without much expense. Bench models are basic physical or virtual prototypes used to test ergonomics or basic mechanisms. They are low fidelity and quick to produce, making them ideal for early testing. Once the concept is refined, detailed engineering prototypes come into play. These are more complex, functional models that simulate real-world performance. They help verify how the product will work in actual use and communicate with manufacturing teams. In practical terms, mechanical engineers use rapid prototyping to test moving parts like gears, pistons, or assemblies. They quickly produce replacement parts for machinery, reducing downtime. Robotics prototypes often combine three-dimensional printed components for complex shapes and CNC machined parts for strength. Using simulation tools alongside physical prototypes helps predict how materials will behave under stress, saving time and resources. In summary, the best ways to prototype new products involve a mix of fast, accurate methods like three-dimensional printing and CNC machining. These are supported by early sketches, simple models, and molding techniques. This approach allows engineers to test ideas thoroughly, reduce risks, and speed up the journey from concept to final product.